Hello everyone, you are all welcome to lecture number 972, and today I am going to discuss about the manufacture of very special rubber that is called silicone rubber. And as we know, the silicone is very important element, and nowadays it has lot of uses in 21st century, and it is also used to manufacture a special type of rubber which is extremely resistant to heat and sunlight. And to manufacture the silicone rubber, we are polymerizing the silicone dimethyl chloride and silicone hydroxide, and in this way the silicone and oxygen atoms, they will be in sequence, and there is no chance of formation of long carbon chain, and because of that reason we will not be having the tensile strength, because not formation of carbon chain, rather than it is oxygen and silicon sequencing. And this rubber is very special type because of its high quality towards sunlight, towards oxidation, that is in presence of atmosphere, and also it is not affected by mineral oil like petroleum or other vegetable oils, and it is very stable in presence of different type of climatic condition and weather, atmosphere, and it is mainly used to manufacture very special type of articles which are stable in extreme temperature from minus 100 degree Fahrenheit to minus 500 degree Fahrenheit. So these are all very important points, and some of the important very special type of rubbers I will be also discussing today. So here I am going to discuss how the silicone rubber is manufactured and how it is vulcanized in presence of peroxide to have the cross link between two SI units. So number one, silicone rubber is manufactured by the polymerization of dimethyl silicone chloride and dihydroxide methyl silicone. So this is dimethyl silicone, and this is dimethyl dihydroxy silicone. When the polymerization will take place, then you will get the silicone rubber. Number two, in silicone rubbers, the chain structure does not involve a long chain of carbon. There is nothing like long chain of carbon, rather than it is the sequence of silicon, oxygen, silicon, oxygen, silicon, oxygen type of arrangement. Number three, in interchain forces in silicone rubber is extremely weak. So that interchain, because silicon and oxygen interchain linkages, interlink forces are very weak, and that's why it is having weak tensile strength, and hence there is no crystallization of chain on stretching. So the gum tensile strength of the silicone rubber is very low and can be increased by adding reinforced material, and that material is powdered silicone, that is silicone rubber, very low, and reinforced pigment such as fine silicone powder. This fine silicone powder is used as a reinforced material. The silicone rubber can be vulcanized by organic peroxides to form a cross link. So here, this is your organic peroxide. Once this organic peroxide will come in touch of two molecules of silicone raw rubber, this is your silicone raw rubber, then there will be elimination of one molecule of water to two of the hydrogen from two methyl groups, CH3 group will be taken, and oxygen will combine. there will be formation of water, and this water molecule will be eliminated. And by the elimination of water molecule in presence of organic peroxide, these two methyl group, one methyl group of this silicon chain and other methyl group of this silicon, will be converted into CS2 grouping, and this CS2 grouping will give the cross linking, and that's why it will be vulcanized in presence of peroxide, this silicon rubber, and this is your vulcanized silicon rubber to form cross link between the two adjacent chains. Peroxide is effective to remove some of the hydrogen atoms from the silicon atom. So here I have already told you that this peroxide is very effective to remove some of the hydrogens from the silicon atom, and those hydrogens are attached in the form of methyl group. So from that methyl group, one from methyl group of this, one hydrogen is removed and one hydrogen is from this methyl group, and that will make the cross linkage, and what that cross linking will allow the vulcanization of silicon rubber, effective to remove some of the hydrogen atoms from the silicon atoms, and thus allow the carbon atoms of two adjacent chain to couple and form cross link. So adjacent this, and it will be coupled, these two molecules of silicon rubber, and there will be cross linking, and example I have already explained. So actually silicone rubber is a very special type of rubber, and it is manufactured for special purposes, especially in aeronautical engineering department, and even the manufacturing of aircraft, and for that is air jets, fighter jets, as a tire, because these tires, they can resist very high temperature, and even at high temperature the chance of becoming brittle is very less, and once the tire becomes brittle, there is burst, it can be broken down. So to avoid that emergency, we cannot use ordinary tire for aircraft tire for landing purpose, either for aircraft or even for fighter jets. So mostly nowadays in fighter jets and aircraft, we are using silicone rubber, because silicone rubber, the most important property is that it can be stable and strong up to high range of temperatures from -60 to 300 degrees centigrade temperature positive. So from -60 it can be stable from up to 300 degrees centigrade. This is the main property, and of course it is extremely resistant to high temperature. So number 4, that is properties of silicone rubber. Properties of silicone rubber. A, it possesses excellent resistance to prolonged exposure to sunlight, weathering means atmosphere, oxidation. Then it can resist even boiling point, boiling water. So that even the boiling water bag is also manufactured with silicone rubber. So it can resist the boiling water, and it can resist common oils and dilute acids and alkalis. B, silicone rubbers have poor physical properties, yet they maintain their rubber characteristics over the temperature. The main and most important property of this silicone rubber is at very high range of temperature. It is maintained, its properties maintained, it is normal and tough. So over the temperature range of minus 100 degree Fahrenheit to 500 degree Fahrenheit, and they are also resistant to air and ozone over this range. So within this range of temperature, this your silicone rubber is resistant to ozone and oxygen, air. See, silicone rubbers remain flexible. It is flexible in the temperature range of 90 to 250 degrees centigrade temperature. So that is the most important property, that at very high temperature and at very low temperature, big range of temperature, its flexibility is not reduced, it is maintained. That's why the chance of burst or broken down in pieces is very less. It will not become brittle in the long range of temperatures, and that range is given 90 to 250 degrees centigrade, and hence used in making tires for aircrafts and fighter jets, because the present it prevents the damage on landing. Ordinary rubber tires becomes brittle and undergoes disintegration. If we are using ordinary automobile tires for aircraft purpose, it will become brittle and it will be disintegrated. So to avoid such accident and disintegration, that's why silicone rubber nowadays is very popular rubber to use for not only automobile industry but also in aeronautical as well as aircraft and fighter jets. At very high temperature, silicone rubber bind non-conducting silica, that is SiO2, instead of carbon tar. D. Silicone rubber is mainly used in making lubricants, paints and protective coating for fabrics, water proofing. It is also used as a sealing material in search lights and in aircraft engines as an adhesive, for making an insulation for washing machines and electric blankets, for iron board covers. Actually, wherever high temperature is required, it is used as a blanket, as a jacket, as an adhesive, and it will not be disintegrated. So here the special type of rubber, we call it silicone rubber, and its monomer, this is the monomer, that is dihydroxy dimethyl silicone, and this dihydroxy dimethyl silicone will form the polymer. Polymerization will take place by arrangement of the sequence of silicon and oxygen bonding, and that is your silicone rubber. So with this special type of rubber, that is silicone rubber, today I will stop, and in the next lecture again I am going to discuss some more special type of rubber. Once again, thank you very much for watching the lecture.